Hi guys, this is Joy. Today I'm gonna show you how to use multisim for measuring the characteristic impedance of a symmetrical network. So we will first open those files. Before going into details, at first, what is characteristic impedance? Characteristic impedance is a basic characteristic property of symmetrical network, which defines its basic characteristics, and that's why the name characteristic impedance. That is an impedance that is measured in terms of open circuit impedance and short circuit impedance. How? I will explain. First, I have taken this simple T network of series arm impedances of 100 ohms and 150 ohms. Now, what is the problem statement? Problem statement is to find the characteristic impedance of a given T network with series arm impedance of 200 ohms and shunt arm impedance of 150 ohms. Why 200 ohms? Because for here we write Z by 2 and Z by 2 here, that such that the total series arm impedance remains Z. That is, Z is 200 ohms, Z by 2 is 100 ohms each. And for measuring the characteristic impedance, we have taken this two-port network replicated here, and this is say port 1, this is say port 2. We have made port 1 open and measured the impedance from here. Rather, here it is resistance, that is 250 ohms. That is called the open circuit impedance. That is here set up for measuring the open circuit impedance. As this port is open, and we have measured impedance from here. Similarly, we have made port 1 shorted and measured the impedance from here. That is 160 ohms. It is 250 and this is 160 ohms. And for measuring or checking the finding the characteristic impedance, we need to use the formula that is Z naught, characteristic impedance Z naught, that is equals to square root of the multiplication of ZOC into ZSC. So ZOC is how much? 250, and ZOC is how much? 160. Multiply these two, that is 250 into 160. I found this is 40,000, and if we square root this one, that is to the power 0.5, we have found it 200. So characteristic impedance is found to be 200, and which I have connected here. 200 is connected here, and what we found from here, it is 200 ohms exactly. That is the main property of a symmetrical network, or characteristic impedance rather. That is, if the characteristic impedance value is known, and we take a symmetrical network, we connected the at one port of the network with the same value of the characteristic impedance, and we check from the other port of a two-port network, we get the same. That's a very important characteristic of a symmetrical network in order to measure the several characteristics of transmission lines or some other networks as well. Now we will move into another characteristic impedance measurement for symmetrical pi network. We have simply taken this problem statement of finding the characteristic impedance of symmetrical pi network of series arm impedance of 200 ohms, series arm impedance of it should be 100 ohms rather, 100 ohms, and shunt arm impedance of 75 ohms. Why is 75 ohms? Because we write here 2Z parallel 2Z, so that the overall effect becomes Z, that is 150 parallel 150 becomes 75, so shunt arm impedance equal to 75. And again we will measure the open circuit impedance from here, which is found to be with 93.75 ohms. We will measure the short circuit impedance here, making port 1 shorted, which is found to be 60 ohms, and the characteristic impedance should be 75 ohms. Let's check whether it is 75 ohms or not. 93.75 multiplied by 60, which is found to be this one. Next square root this one, which is 75, and we have terminated this port 1 with 75 ohms and found exactly 75 ohms from this port. So this is all for characteristic impedance, which is very important characteristic of a symmetrical network, and it is not shown in asymmetrical networks. So that is, if we took some resistances other than 100 ohms here, we wouldn't have get this result. We would have get some other result like irritative impedance or some other image impedance or some other, etc, etc. And we will get this characteristic impedance property only by using the symmetrical network, symmetrical T, symmetrical pi, or any other sort of symmetrical networks. So we can get this sort of outcomes from here, which is very important characteristic. I repeatedly telling, it is used in transmission line characteristics measurements, that is distortion analysis, noise analysis, attenuation analysis, etc, etc. All they are incorporated in that sort of analysis of transmission lines. So I hope you have understood all the topics. That's all for today. Next time we see you, we will be learning about network theorems. That's all for today. Goodbye.